We are now at module number 16, and this is a fairly easy module because it's basically just explaining one more application of the Le Chatelier's principle. Okay, I thought we were getting into our calculations, but actually that'll be our next module. So this one's pretty easy, and there's kind of some interesting little videos to watch for this one. I'm not going to talk very long at all for this. So we have already explained one application of Le Chatelier's principle. Do you remember what that one was? To produce fertilizer? That was the Haber process, okay? Here's the second major application of Le Chatelier's principle, so chemistry in real life, and this is one that I bet you've heard of before. What if you get carbon monoxide poisoning? How do scientists and doctors treat you? Okay, well, there's something called the hyperbaric chamber. So that's what I've got a little video down below. This video actually is really good. The doctor in this video talks quite a bit.
The hyperbaric chamber is a piece of medical equipment that provides 100% oxygen at increased pressures, usually 2 to 3 times atmospheric pressure.
Okay, and what they're going to do is just explain how does that work then. So in a pressurized system, how can you shift the equilibrium in your body so that the carbon monoxide will stick less to the hemoglobin, and then your hemoglobin can continue to carry more oxygen as you go. Okay, so this entire module again is fairly work on your own. It's fairly easy. It just covers pages 13 to 16. So this is why I said don't even bother printing out these ones. Page number 16 has this summary, and you're fine if you just concentrate on this little summary right here. You might not even need to write anything down. You can just have a look at the equilibrium and see if you understand the application, okay? So don't bother printing too much for this one. Again, just make your own handwritten summary, or not at all. Just read through it if you'd like, okay? So you've got an equilibrium right here, okay? So this is on page number 16, and this is our summary of our equilibrium that we would end up having. So here we've got hemoglobin bonding with your oxygen. So hemoglobin's that complex protein that you've got in your red blood cells, and your red blood cells attach those 4 molecules of oxygen to each molecule of hemoglobin, okay? If you're in a situation where you have carbon monoxide, because again, there's been some sort of issue where you are finding an environment with a high concentration of carbon monoxide, the carbon monoxide will actually bind to the hemoglobin, and then you have less oxygen available in your blood, and that's how you can end up with carbon monoxide poisoning, okay? So when you are in a hyperbaric chamber, you are essentially stressing this equilibrium equation with an increase in oxygen concentration. What's that going to do? Well, we talk again in the same terminology. You're going to shift that equilibrium towards the reactants, towards the left. Can you explain that using the collision theory? Sure. You have greater concentration of the molecules. You're going to have more collisions, more successful collisions at an energy that's less than or equal to the energy of activation. You're going to increase the rate of the reverse reaction until a new equilibrium is established. And that's your result. You're going to have an increase in the molecules of hemoglobin to oxygen, and then you're going to be able to leave that carbon monoxide out. Okay, so there's your great little summary right there, and it's kind of nice to just sort of see it all as an equilibrium equation, what's happening as the stress, what's the shift, what's the result, and that can simply explain using Le Chatelier's principle. Okay, so that's it for this module. I'll also post on there a nice little video about what happens to divers if they get the bends because they have too much nitrogen bubbles in their blood. If they're under high pressure, when they're underneath the surface of the water really deep. And if you're a lifeguard, you've probably already gone over this before, but it's kind of another application of being able to see what happens with pressure on a system where you've got gases, and then if those gases come out of your bloodstream, and instead of being aqueous gas, they're now gases, and then those gases can have a tremendous impact on the body, and that's referred to as the bends. So again, a nice little application of Le Chatelier, and that's it for module number, what are we on? Module number 16. We're done. See you next time.